Hey guys, thanks for stopping to pause for a moment of science, and I just want to talk to you today about gravity. A few years ago I was teaching a science lesson and was talking to the students about how you can drop objects in the air and they will hit the ground at the same time. And we talked about, a car key, a rock, a marble, a golf ball. Hey Una. Hi Uni. And the students didn't believe me. And one student said, well, what about like a soccer ball and a bowling ball? So I got a soccer ball, I got a bowling ball, I got my class, took them outside, and dropped them from a very high point in the school, top of the cafeteria, and proved to the students that they will in fact hit the ground at the same time. And it looked like this. Since then, I've realized that that is an experiment that's pretty tough to simulate, and I want the kids to be able to do it themselves and to keep them from climbing on top of the school cafeteria and dropping objects off the side. I thought it might be smarter to find a much more safe and economical way to teach the same concept. And so what I did was I found two of these balls. One is a very, very lightweight wooden ball. It almost feels hollow on the inside. It's such a very lightweight type of wood. And then, of course, when I was growing up, these were called steelies. It's like a ball bearing. It is a steel, solid, very heavy ball bearing. And you can see that they are about the same size, about the same shape. They, of course, are different mass and they are different weight. But they will both be a victim to gravity. Gravity pulls at 9.8 meters per second squared on all objects. And so the way I explain this on a 5th grade level is that gravity pulls all objects through the air the same. Weight is the amount of gravity that pulls on an object, but weight can only be calculated on a surface. You can only calculate weight when it's actually the object is on some type of surface. When an object is free falling through the air, weight is a non-factor. And so that's why gravity pulls on all things equally. Now, of course, if there is a sheet of paper that is flat and a sheet of paper that's crumpled up into a ball, if I drop them, there will be a difference because the flat sheet of paper is going to pick up drag, air resistance, and it will slow it down as it is pulled back down to the earth. I'm going to show you a really quick video about what that looks like inside the classroom.